video to look at fully factorising two terms. And obviously we've got algebra in these terms. So let's start with a sort of rationale about factorising. If I take two numbers, 12 and 8, I could factorise both of these numbers to see if they have a shared factor. So I could write 12 as 2 times 6, and I could write 8 as 2 times 4. And then I can immediately see, let's go to a different colour, that they have a shared factor of 2. So they have a shared factor of 2. But if you go back to those numbers, you can probably see that they're going to have a higher factor. If we were looking for the highest common factor, it's going to be 4. So what we've done is not wrong. We've found a shared factor. But what we haven't done is found the highest common factor. And fully factorise really means the same thing. We're looking for the highest common factor. So why didn't we find it by factorising? Because we broke up the number, we broke up both numbers, but we didn't break them right down to a product of their primes. So let's do that now and see if it helps. So we've got 2 there, but 6 can be broken up into 2 times 3. And then moving on to our 8, 4 can be broken up to 2 times 2. So only by breaking it down to show it as a product of its prime factors can we really compare. However, obviously with the numbers like this, we can probably do it without any thought. But we need to see how things work so that we become more confident when we look at things that aren't so obvious. Now we can see that they do in fact share a combined factor of 2 times 2. So their highest common factor is 4. At this stage, we have found a factor, and if we looked at the product of this, it would go to 12, would be 12. And if we looked at the product of this, it would be 8. But not until we break it down into all of its factors can we be sure that we've found them all. So there's the rationale, which will hopefully help us when we move on to algebra. So let's get rid of that. In fact, let's get rid of that altogether. And what I'm going to do, just to make it really, really clear, is I'm going to write each of these terms out in full. So 9x cubed y squared is going to be 3 times 3 times x times x times x times y times y. Okay, and don't forget, any moment you can stop this, pause this video, have a think about it, or try things out. 12 is 2 times 2 times 3 times x times x times y. So there's those two terms. They're going to be added together in entirety. If we break it down, that's what they would be. Now let's look for what they have in common. So no 2's for the first one, so we can skip that, but they do have a 3 in common. And number-wise, that's all they have in common. So let's put that 3 there. Now let's look at x's. We've got an x there and an x there. We've got another x there and another x there. So we can take out x times x, which is x squared, because they both have that in common. This one's got another x, but that's no good to us because there isn't one here. It's not common to both terms. And then finally, let's look at the y's. Well, they've both got a y, so we can factor that out too. So now we have fully factorised those terms because we have found their highest common factors. Okay, so next job, we've taken out a common factor. What we need to do is see what remains. And let's remember that factorising is a division. So what we're going to say to ourselves, if we divide by 3x squared y, what would remain of the first term and what would remain of the second term. So let's go for it. 9 divided by 3 is 3. X cubed divided by x squared leaves x, and y squared divided by y leaves y. So this times this will give us a product of that. Now let's look at the second term. So 12 divided by 3 leaves us 4. And then we've got x squared y here and x squared y here. So x squared y divided by x squared y is just going to leave 1. We don't need to write times 1. So that's it. We are done. And that is fully factorised. Now, if we multiplied out the brackets, we would get back to where we started from. Okay. And that is one way of checking whether what you have put in here is correct. But let's just look at one more thing. And let's get clear in our heads that when we are fully factorising, we're not changing the value of this expression. We are just writing it as its two factors. The highest common shared factor and then the remaining factor of each term. And we have to put them in brackets because they'd need to be multiplied out to get back to where we started. So this time we're just going to not fully factorise. So for an example, we might see that 9 and 12 have a shared factor of 3. I think that's really straightforward. And then we might say, well, this has got a shared factor of x. And then we've got a shared factor of y. So you might do that. And then we'd see what was left. So 9 divided by 3 is 3. X cubed divided by x is x squared. Y squared divided by y is y. So we'd be left with that in the first term. And then if we go to the second term, 12 divided by 3 is 4. X squared divided by x is x. Y divided by y is 1. So we're done. So we have factorised. We have definitely done this. And if you multiplied out the brackets, it would take you back to this. So you haven't done anything wrong, but there remains a common factor within these brackets. There is a common factor of x. Well, we've still got an x in each term. We have partially factorised. We have not fully factorised. And the reason that the brackets will still multiply out to get back to this is because here, if we took out x squared, it would get multiplied by x. Here, we've taken out x, and it's going to get multiplied by x squared. So it's absolutely going to take us back to where we started from. But the point is, it's not fully factorised. We could still take out a common factor of x. I'm going to give you one more example if you need it. So if you're happy with that, you can stop here. But if I write this fraction, 16 over 20, and that is equivalent to 0.8 as a decimal. If I partially factorise this, so I take out a factor of 2, I'm going to get 8/10, which clearly is still 0.8. So I've factorised it. I haven't changed the value of it. I haven't changed the value of it at all. But I also haven't fully simplified it. I can still take out another factor. And that would take us to 4/5, which of course is also 0.8. So this isn't wrong at this stage. It's just not fully factorised. So we're not looking at the simplest answer to this this fraction. If we had immediately gone for divide by 4, then we would have fully factorised. Okay, I hope that's helpful. And that's the end of this video.